After controlling the motor's forward, reverse, left and right movements, now we will cover IR sensors. The GalaxyRVR Rover has two IR sensors, one on the right side and one on the left side. The right IR sensor is connected to pin 7 on the Arduino Uno and the left side IR sensor is connected to pin 8. First, you need to set the alignment of these two sensors. Next, you need to set their detection range. To do this, first turn on the GalaxyRVR Rover, then use your hand or an object to check if both sensors are detecting properly. If the distance is too short or too long, you can adjust the range using the potentiometers on the IR sensor. After setting the alignment and range of the IR sensors, now we can start with the programming. First, we define the two pins our IR sensors are connected to. There are certain rules when it comes to defining variables. I have already covered it in my Arduino course. It's completely free. You can find a link in the description. I'm sure you already know about the setup function. It's a special function that executes only once when the Arduino board is powered up or reset. Since we are going to use IR sensors for detecting objects and humans, so that's why we need to set the IR sensor pins to input mode, meaning they will receive the signals. Next, you will need to activate the serial communication if you want to send messages to the computer and get them printed on the serial monitor. We want to check if the IR sensors detect objects. Anyway, inside the parentheses, you can see this number 9600. It's the baud rate. Loop is also a special function like the setup function, but the loop function runs repeatedly over and over again. Since the IR sensors we are using are digital, so that's why we are using digital read functions. If we were using analog IR sensors, then we would use analog read functions. So we use the digital read function to check if the IR sensor is blocked by any object or human. Let me tell you, when there is nothing in front of the IR sensor, you get 1, and when it detects anything, then it gives 0. Anyway, after reading the IR sensors, then we print it on the serial monitor. Let's upload this program. Now, let's turn the GalaxyRVR in an obstacle avoidance robot. We are going to use the same library and the same pins on the Arduino to control all the 6 motors. We can't change these pins because of the hardware limitations. They have already defined the connection, so you will have to use the same pins when it comes to controlling the motors on the GalaxyRVR Rover. The IR sensor pins definitions and code inside the setup function remains exactly the same. The soft PWM begin function is for the PWM. If you remember, we used it in the first lesson. Inside the loop function, first we check the IR sensors and store the pin status in variables right value and left value. Next, we use if conditions to check if only one IR sensor is blocked or both the IR sensors are blocked. 0 means there is something in front of the IR sensor and 1 means there is nothing. Take a look at the first condition. We are telling the controller to bake right if there is something in front of the right IR sensor. Then in the second condition, we are telling the controller to bake left if there is something in front of the left IR sensor. And in third condition, we are telling the controller to move the robot backward. You can also stop the robot. Else, if there is nothing in front of both the IR sensors, then the controller moves the GalaxyRVR in the forward direction. Don't get confused with these user-defined functions. I have already covered these in the first lesson. Let's upload the program. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.